Hello, welcome to the Electronicom workshop. Today in the workshop, we are going to talk about logic gate. That is logic gate. That is logic gate. There are two words here, logic gate. So we are going to consider these two words one after the other. Now let's take gate. What do you understand by the word gate? In electronics, when we talk about gate, we actually think of a switch. For instance, if you have a circuit, you have the positive and then you connect a switch here, and then you have the circuit here and the negative terminal, and then you apply a volt here. So now this is a circuit powered by 5 volts. But this 5 volts cannot power this circuit because the switch here is open. So if you want to power this circuit, you have to press this key so that the 5 volts will be able to power the circuit. So the function of this switch here is to control the voltage in to the circuit and then also to cut off the voltage from the circuit. That is to switch on the circuit and to switch off the circuit. That is exactly what we mean by a gate. Now we talk about logic. Logic here is just a reason. It can be any reason, just a good reason, sensible reason, scientific reasons. It can be electronic reason. So if you add a gate here, then this is actually logic gate. So what this stands for here is that since the gate is just there to open and close, on and off, then it is happening for a good reason. For instance, if you open the gate, you are opening the gate for a good reason. That is logic, for a good reason. If you are closing the gate, you are closing the gate also for a good reason. That is exactly what this whole world stands for. Now, we have different types of electronic gate. Now let's talk about one, and that is the AND gate. Now, what is the AND gate? The AND gate is when two switches are connected in series to a particular circuit to control the circuit. That is to switch on the circuit and then also to switch off the circuit. Now, let's say we have the positive, this is the first key, and then the second key connected in series with a circuit. Now we have switch 1. Let's say this is the A switch and the B switch. Now if you apply 5 volts here, you want to power this circuit here. The voltage will move through this point, but it will stop in the A switch because the A switch is open. But if you close this switch A, the voltage will now flow from this point through into the switch A, and here it will stop in the switch B because the switch B here is open. So this circuit cannot be energized. But if you close it this way, the voltage will now pass through switch A and switch B, and then this circuit will be definitely power. So if you want this 5 volts to power this circuit, A and B switch must be closed. If any one of these switch is open, then you cannot energize the circuit. Both of these switch must be closed so that you can power the circuit. In electronics, when we talk about 0, we mean off. When we also talk about 1, meaning it is on. It is the same thing, 0 here, 0 here is open, and 1 here is closed, because when the switch is open, no current flows to the circuit, so there is no output. But when the switch are closed, the voltage will power the circuit. Now, the truth table, the circuit symbol for the AND gate is like this. This is just a rough diagram of the AND gate circuit diagram. Now D here is the output. We have the A switch and then we have the B switch here. Now this is the A switch and this is the B switch here. Now, what is actually the truth table of the AND gate? Now we have A switch here plus the B switch equals to D. D here is the output. Now we have both switch A and switch B in this circuit. We also have the A here and then we have the B here, and this circuit here is the D circuit. This is the output. So now, if this key A, if a voltage is being applied here and this key A is 0, you know that 0 here is actually open or it is off. And also this other circuit is also open, just like here. If A switch is open and B switch is open, then there is going to be no current. So if we have the A here open and the B switch also open, then the output is going to be 0. Now, if we close the A switch here, leaving the B switch open, current will flow through this A switch, but it will not flow through the B switch because B here is open. So there is not going to be any voltage to the circuit. So if we have the A closed here and leaving the B closed, current will travel here, but it will not travel here because the switch B here is open. So there is not going to be any voltage to the circuit. So the circuit is still off. Now, if also we leave the A open and then we close the B, what will you think will happen? If we will leave the A switch open and then we close the B switch, first of all, the voltage will not pass through the A switch because it is open, and the B here is closed. But since voltage cannot pass through the A, there is no voltage even to the B to energize the circuit. So the circuit is not going to energize. So here is also off. The circuit will remain still off. So in this case, if we have the A switch open and the B switch closed, then voltage will not pass here because the A switch here is only an open. So the output here is going to remain off. Now, but in case we close the A switch and the B switch, in case we close the A switch and the B switch is now closed, so voltage can now pass through the A switch, also through the B switch, and then power the whole circuit. So the circuit will started running. So if we close the A here, the A switch and the B switch and the B switch here, then there is the B switch also closed. We have both switches closed, then the output is going to be 1 2. It is going to be on, because voltage cannot pass through the two switches and energize the circuit, because A here is closed and B here is also closed. So thank you very much for your audience. The next video we will practically demonstrate what we have actually illustrated here. We will demonstrate practically our explanations that we have actually demonstrated. We have actually illustrated in the theory aspect. Please don't forget to subscribe, share, and like. Thank you very much. Thank you once more again.